Okay, so our next topic is fluid kinematics. So we have already dealt with fluid statics, and fluid statics is nothing but study of fluid in rest. Now coming to study of fluid in motion. Now when we talk of motion, two things comes into picture, which is the study of fluid in motion is divided into two parts. First part is the kinematics and second is the dynamics. Okay, now what is kinematics? Kinematics means study of position, velocity, acceleration without considering the forces which are causing that motion. Okay, study of motion without considering the forces causing the motion is called as kinematics. And next is dynamics. Dynamics means when we study of the forces which are causing that motion, then that comes under dynamics. Okay, so in this particular unit we will be dealing with the kinematics. That means we will be dealing with the velocity, acceleration, position of the motion of the fluid. Okay, now when we talk of the motion, the quantitatively we can define motion in terms of velocity, and velocity, as we know, is a vector quantity. Okay, and how can this velocity be expressed? Now very basic things. Suppose the velocity in x direction, y direction and z direction are u, v and w respectively. Okay, so velocity vector will be equal to what? U I cap plus v j cap plus w k cap, as we all know. And if I want to determine the magnitude of this velocity, so this magnitude of this velocity will be equal to under root of u square plus v square plus w square. Getting these all things we have already done. Okay, now what is this u here? So this u is nothing but dx by dt, change in position of in x axis with respect to time, and this u is a function of x, y, z and t. Similarly, v is equal to dy by dt, and which is a function, again a function of x, y, z and t, and w is equal to change in position of z axis, which is equal to w is also a function of x, y, z and t. Okay, change in position with respect to time is nothing but the velocity. Okay, so this is a very simple thing, and we will deal a very simple question related to this, and then we will move forward. Okay, now let's suppose it is given in the question that u, which is a function of x, y, z and t, is equal to 6xy square plus t. Okay, v is given as 3yz plus t square plus 5, and w is given as 2 plus 3ty. Okay, now we want to determine velocity at point P. At point P, whose coordinates are 4, 1 and 2 at time 3 seconds. Getting this? Okay, now how to solve this? Very simple to solve. First we have to determine the value of this velocities u, v and w. We have the coordinate 4, 1 and 2, and time is given as 3 seconds. So we can easily determine this u. So this u will be equal to 6 into x is 4 into 1 square plus 3, which is equal to 27 meter per second. Okay, now v is equal to 3 yz, y is 1 into z is y into z, which is 2 plus 3 square plus 5, which is equal to 20 meter per second, and w is equal to 2 plus 3 into y is 1, which is equal to 11 meter per second. Okay, so this is the value of u, v and w. Now how can we determine the velocity at point P? So velocity vector here will be equal to what? U I cap plus v j cap plus w k cap. So this will be 27 I cap plus 20 j cap plus 11 k cap, or you can say this velocity v is equal to under root of 27 square plus 20 square plus 11 square. So this will be equal to 35.35 meter per second. This is answer. Okay, now this was just to recall your concept of vector, of velocity vectors. Velocity, as I told you, can be represented as ui plus vj plus wk, and velocity magnitude is equal to under root of u square plus v square plus w square. Okay, now coming to the classification of flow, very important. Okay, so the flow can be classified in different forms. The very first is the steady and unsteady flow. Now what is an steady flow? If different properties of the flow such as density, velocity, acceleration, discharge, this does not change with respect to time at a particular location. The properties does not change with respect to time at a particular location, then we can call it as a steady flow. Now what does this mean? This means suppose this is our flow, and at any particular coordinate system, at any particular space coordinate, suppose x naught, y naught, z naught, suppose the velocity at this particular point is rho v, density is rho, acceleration is a, and discharge is suppose q. Okay, now throughout the flow at this particular point the properties will remain same. The density will be rho throughout the flow, velocity will be v throughout the flow, and so on. Now it may change at different space coordinate. That means this is point 0, here the velocity is v naught, rho naught. Suppose at point 1 velocity is v1, rho 1, a1, and so on. That means it may change with respect to space coordinate. At different point you may have different properties, but at that particular point throughout the flow the properties will remain same. This is called as the steady flow. That means the properties are not changing with respect to time at a particular coordinate, then we can call it as steady flow. Okay, so in the form of equation, how can we write this? So for a steady flow, the properties does not change with respect to time. That means del v by del t at x naught, y naught, z naught is equal to 0. Okay, similarly pressure del p by del t at x naught, y naught, z naught is equal to 0. Similarly density del rho by del t at x naught, y naught, z naught is equal to 0. Similarly discharge del q by del t at x naught, y naught, z naught is equal to 0. Okay, that means the velocity, the pressure, the acceleration, the discharge, all these properties does not change with respect to time at a particular coordinate, at a particular space coordinate. Then we can call it as steady flow. Okay, now for unsteady flow, these properties can change with respect to time. Okay, that means del v by del t at x naught, y naught, z naught is not equal to 0. Del p by del t not equal to 0. Del rho by del t not equal to 0, and del q by del t is not equal to 0. So all these properties can change, may change with respect to time at a particular space coordinate, is called as unsteady flow. Okay, so this is how we can define this steady and unsteady flow. Now next classification is the uniform and non-uniform flow. Now what is a uniform flow? Now if the velocity vector does not change with respect to space coordinate at a particular time, then that is called as a uniform flow. If the velocity vector at all points, or you can say the velocity vector at all points in the flow at a particular time is same. That means suppose this is our flow at any particular time, suppose t naught, the velocity at this point 1 is suppose v, the velocity vector is v. So at this particular time the velocity at all the points should be v only. That means velocity is not changing with respect to space coordinate at a particular time. Okay, now if suppose if the time changes, the velocity may change, but at that particular point of time the velocity does not change with respect to space coordinate, then we can call it as uniform flow. Okay, that means you can say for uniform flow, del v by del s at t naught is equal to 0. Okay, similarly for non-uniform flow, del v by del s at t naught is not equal to 0. That means the velocity vector at all points in the flow is same, and when I say velocity vector I mean the magnitude as well as direction of the velocity vector at that particular instant. Then we can say that the flow is uniform. And if the velocity vector is not same, in either in magnitude or in direction or both at all coordinate at a particular time, then we can say that this is a non-uniform flow. Now this uniform flow is possible in a pipe of uniform diameter. Suppose we are having a pipe which is having a uniform diameter and there are no more leakages. Okay, then we can assume that the flow here will be uniform. Okay, and non-uniform flow, suppose we are having a tapered pipe like this. Okay, so here the magnitude of this pipe is because the area of this pipe is continuously changing, so the magnitude of the velocity will continuously change, so we can call this flow as a non-uniform flow. In tapered pipe the flow is non-uniform, and in a uniform area pipe we can call the flow is the uniform flow. Okay, next is 3D, 2D and 1D flow. Next type of classification is 3D, 2D and 1D flow. 3-dimensional, 2-dimensional and 1-dimensional flow. Okay, now how can we classify this? For unsteady flow and for steady flow. Now if the flow is 3-dimensional, now the velocity, as I told you, will be the function of x, y, z as well as time. Why time? Because this is an unsteady flow. This may change with respect to time. Okay, and if it is a steady flow, obviously the time will not be factor, it will not change with respect to time, so the velocity will be function of only x, y and z. Getting this or not? Similarly for 2D flow, velocity is a function of x, y, only 2-dimensional coordinate and t, and here for a steady flow t will not be there, velocity will be just a function of x and y. Similarly if we are having 1D flow, then velocity here is a function of x and t, and if it is a steady flow, velocity will be function of only x. Okay, if I give you the example 3D, for 3D flow you can say the flood. Okay, the flood, which is the direction of flow of in the flood in all direction, in x direction, y direction as well as in z direction. Okay, 2D flow between parallel plates. Okay, when the fluid is flowing between two parallel plates, then we can call it as the 2D flow. 1D flow, the flow in pressure pipes. Well, this is how you can understand with the help of example the 2D, 3D and 1D flow. Okay, flow in the pressure pipe only in one direction, the velocity. Now this one-dimensional flow is actually practically not possible because the velocity cannot change just in one direction. Okay, we may say that velocity is changing only in this direction, but the matter of fact is that velocity always changes in y direction also. As I told you, because of friction, because of viscous effect, the velocity always changes in y direction. Okay, so velocity, the flow can never be a 1D flow, it can be either a 2D flow or it can be a 3D flow. 1D flow is not possible because velocity may change, velocity changes always in y direction also. Getting this or not? Okay, so you can write down the note, the flow is never truly one-dimensional because viscosity causes the fluid velocity to decrease at zero at the boundaries. Okay, now next classification is the laminar and turbulent flow. Okay, now laminar flow means if the flow is smooth, the path is a regular path and the flow can be predicted well in advance. We can predict the flow that at this particular time the flow is here, after this time the flow will be here. That is a smooth path. The layers do not intermix with each other. That kind of flow is known as the laminar flow. Okay, now what is the turbulent flow? Okay, so such type of flow is called as the laminar flow, in which the fluid particles, fluid layers do not intermix with each other. Okay, the flow is smooth and the path is regular path. Okay, this is laminar flow. Okay, now what is a turbulent flow? So in turbulent flow, the fluid particles, the fluid layers intermix with each other. The flow is very much unpredictable like this. The different particles follow like this. erratic flow you can call. This is the turbulent flow, which cannot be predicted in advance. Such flow is called as the turbulent flow. Getting this? Okay, so in laminar flow, the fluid particles move along smooth, regular path which can be predicted well in advance. For example, flow through a small diameter tube with low velocity is generally laminar. The turbulent flow is characterized by random and erratic movement of fluid particles resulting in the formation of eddies. Okay, so eddies will be formed in this turbulent flow. Next is the streamline and flow line. Next topic is okay. Now what is a streamline? Streamline is an imaginary line which is drawn in such a way that the tangent at any point will give the direction of flow, the velocity of flow at that particular point. Okay, the imaginary line such that if I draw tangent at any point of that line, of that imaginary line, I will get the velocity of flow at that particular point. Okay, such line is called as the streamline. Now velocity of flow we are getting, that means obviously this is also the direction of flow. Okay, this streamline will always be in the direction of flow, and that's why this is also called as the flow line. Okay, so how can we define the streamline? Imaginary line, the tangent to which at any point gives velocity at that point. Getting this now? Okay, now in case of a steady flow, in a steady flow, obviously this streamline will be permanent. Why permanent? Because the velocity does not changes with respect to time. At a particular space coordinate, the velocity does not change with respect to time. So obviously in a steady flow, this streamline will be a constant because this velocity at any point is not changing with respect to time. Okay, now whereas in unsteady flow the velocity changes with respect to time, so the streamline will be temporary, or you can call it as instantaneous streamline. Okay, so another important thing, in a steady flow streamlines are permanent. In case of unsteady flow, the streamlines are temporary, or you can call it as instantaneous. Okay, now we know what time is equal to ds by v, distance upon velocity. Okay, or you can say this t is equal to dx by u plus dy by v plus dz by w. Now how will be the streamline equation? Okay, so we know what time is equal to ds by v, the distance upon velocity, or you can say this time is equal to dx upon u, in x direction the velocity is u, or you can say dy by v, or you can say dz by w. Okay, so this is nothing but the streamline equation. Dx by u is equal to dy by v is equal to dz by w. Okay, this equation is nothing but streamline equation. Okay, or you can say from here this v dx minus u dy should be equal to 0, w dy minus v dz should be equal to 0. Okay, or w dx minus u dz should be equal to 0. Okay, so this is nothing but the streamline equation. So if you want to know whether the flow is a streamlined flow or not, so what you have to do is you just have to check this equation. If the flow fits into this equation, then you can say that the flow is a streamlined flow, or else it is not a streamlined flow. Okay, so these all equations are the streamline equation. Getting this? Okay, now next is the path lines. Now what is the path lines? Okay, now streamline is the tracing of the motion of bulk mass of the fluid. Okay, streamline means you are tracing the motion of bulk mass, like this, the whole mass of the fluid is getting traced. Now if you are tracing the individual particle motion, of single particle, then it becomes your path line. Okay, that means you are having a single particle, and if you are considering a single particle, and if you are tracing the motion of that particular particle, okay, then this becomes path line. Getting this or not? Getting the difference between streamline and path line? Streamlines means tracing of the complete mass, whole mass of the fluid, the bulk mass of the fluid is called as a streamline. Okay, streamlines gives you the flow of discharge, the flow of the direction of the fluid, the bulk mass. Okay, and the path lines means when you are tracing the individual particle, okay, the motion of individual particle, then it becomes a path line. Okay, this is the difference between streamline and path line. Now one more terminology is there, that is streak line. Now what is this streak line? Streak line at any instant of time is the locus of the temporary locations of all the particles that have passed through a fixed point in the flow field. Locus of the temporary location of all the particles that have passed through the fixed point in the flow field. Now what does this mean? Now suppose we are considering a point, suppose P, and here I am having different fluid particles. Let's suppose particle 1, 2 and 3. Okay. Now these 3 different particles will trace different path. Now after time dt, the particle 1 has traced the path A and reached the point, suppose at Q, after time dt. Similarly, the particle 2 is moving in another path. This is tracing the path B and finally reached the point R. And similarly, particle 3 is tracing another path C, this is path B, and finally reaching to the point as S. Okay. Now after time dt, after a certain time, if I trace the locus of all these points, that means all the particles which have started from the same point has reached different points after time dt. So if I trace all these particles, the final location of all these particles, I will get one line. The locus of all these particles, I will get one line. So this line is nothing but the streak line. Okay, again I will define it. Just listen this carefully. Streak line at any instant of time is the locus of temporary location of all the particles that have passed through the fixed point in the flow field. Locus of temporary locations of all the particles that have passed through the fixed point in the flow field. Getting this or not? Okay, that means the 3 different particle 1, 2, 3, they have traveled through PAQ, PBR and PCS. Okay, these 3 particles have traveled through this different path A, B and C. Okay, after time dt, they have reached Q, R and S. So the locus of these points Q, R, S and P, the locus of all these points will give you the streak line. Getting this or not? Okay, so now you can write a very important note. The streamline, path line and streak line, these are virtually identical for a steady flow. Okay, so if we are having a steady flow, then the streamline, the path line and the streak lines, these are all virtually identical. Okay, next is the stream tube. Okay, now what is this stream tube? This stream tube is the imaginary tube which is bounded by number of streamlines. The imaginary tube like this. Okay, if we are having a number of streamlines in this imaginary tube, and this becomes stream tube. Okay, it is an imaginary tube bounded by number of streamlines. Okay, now we will solve one question. Okay, the velocity distribution for a 3D flow is given by u is equal to minus x, v is equal to 2y and w is equal to 3 minus z. Find the equation of a streamline passing through 1, 1, 2. Okay, so I told you how to find the equation of a streamline. So what is the equation of a streamline? So as I told you, dx by u is equal to dy by v is equal to dz by w. Okay, now u, v and w are given. Okay, so you can write it as what? So this will be equal to dx upon minus x is equal to dy upon 2y is equal to dz upon 3 minus z. Okay, so how can we find the equation here? So this will be equal to dx upon minus x is equal to dy by 2y. Okay, now taking log both, integrating both sides. Okay, so after integration we will get what? Minus ln of x is equal to, this will be equal to half ln of y plus a constant a. Okay, now how can we determine the value of this constant? So we have the coordinate as 1, 1 and 2. So at 1, 1, 2, okay, now minus ln of 1 is equal to half ln of again 1 plus a. Now ln of 1 log 1 is 0, so from here this a will be equal to 0. Okay, so finally we will get the equation as what? Minus ln of x is equal to half ln of y. Okay, or you can say ln of x to the power minus 1 is equal to ln of y to the power 1 by 2. Okay, so from here this x inverse is equal to under root of y. This is equation number 1. Getting this? Now similarly this dx upon minus x is equal to dz upon 3 minus z. Okay, so again integrating this, so we will get what? So here this will be minus ln of x is equal to minus ln of 3 minus z plus a constant b. Now at x is equal to 1 and z is equal to 2, okay, the coordinates given are 1, 1, 2. Okay, so at x is equal to 1 and z is equal to 2, what we will get? So again this will be equal to ln of 1 which is 0, this is ln of 3 minus 2 which is 1 which is again 0, so this b will be equal to 0 and we will get what? X inverse is equal to 3 minus z to the power of minus 1. This is equation number 2. Okay, so we were having the equation number 1 as x inverse is equal to root of y. Okay, second is x inverse is equal to 3 minus z inverse. Okay, so combining this equation 1 and 2, finally we will get the equation as x is equal to 1 by root y is equal to 3 minus z. Okay, so this is our final equation. X inverse, or you can say 1 by x is equal to 1 by 3 minus z is equal to under root of y. Okay, or this is the final equation, x is equal to root y is equal to 3 minus z. Getting this? So this is how we can determine the streamline equation. Next, coming to the acceleration of fluid particle. Now acceleration, as we know, acceleration in x direction, this will be equal to du by dt limit dt tends to 0, change in velocity with respect to time. Similarly, acceleration in y direction, ay limit dt tends to 0 dv by dt, and acceleration in z direction, az limit dt tends to 0 dw by dt. Okay, now as I have already told you that u is a function of x, y, z and t. Okay, so this can be further written as du by dt. Okay, this will be equal to what? Del u by del x into dx by dt plus del u by del y into dy by dt plus del u by del z into dz by dt plus del u by del t into dt by dt. Getting this or not? Okay, now here this del u by del t, as we know, is nothing but acceleration. Del u by del t limit dt tends to 0, this is nothing but a. Okay, similarly this dx by dt limit dt tends to 0, dx by dt is nothing but u, limit dt tends to 0, dy by dt is nothing but v, and limit dt tends to 0, dz by dt is nothing but w. Getting this? Okay, now just putting all the values, and du by dt is already ax, so this equation for limit dt tends to 0, we will get what? Ax is equal to, okay, this dx by dt is nothing but u, so this will be u del u by del x plus v del u by del y plus w del u by del z plus dt dt gets cancelled out, and we will get what? Del u by del t. Okay, so this is the expression for acceleration in x direction. Similarly, acceleration in y direction will be what? U del v by del x plus v del v by del y plus W del V by del Z plus del V by del T. Okay, and acceleration in Z direction will be equal to what? U del W by del X plus V del W by del Y plus W del W by del Z plus del W by del T. Getting this or not? Okay, now if I want to calculate total acceleration, now what will be the total acceleration here? So this total acceleration A is equal to AXI plus AYJ plus AZK. Okay, now magnitude wise this A will be equal to what? Under root of AX square plus AY square plus AZ square. So we have the value of this AX, AY, AZ here, and so we can determine the value of this A, which is under root of AX square plus AY square plus AZ square. Okay, now you can note one thing here, that here we have two types of terms. First is with respect to change in velocity with respect to time, del U by del T, del V by del T, and del W by del T. And second is change in velocity with respect to space coordinate. So this change in velocity with respect to time is nothing but the local acceleration. This del U by del T, del V by del T, and del W by del T, this is called as the local acceleration. Okay, that means this change in velocity with respect to time, this is nothing but local acceleration. Okay, and rest of the change in velocity with respect to space coordinate is called as the convective or convective acceleration. Okay, so this is local acceleration, very important thing. That terms del U by del T, del V by del T, and del W by del T represents increase in velocity with respect to time and is called as local acceleration or temporal acceleration. Getting this now? Okay, and remaining terms means all the remaining terms like del U by del X, del U by del Y, del U by del Z, del V by del X, del V by del Y, del V by del Z, del W by del X, del W by del Y, and del W by del Z. All these terms are called as the convective acceleration. Remaining term, okay, because this represents change in velocity with respect to space coordinate. The change in velocity with respect to time coordinate is local acceleration. The change in velocity with respect to space coordinate is convective acceleration. Okay, so the remaining terms represents convective acceleration. Okay, now you can say what total acceleration should be equal to what? Total acceleration should be equal to local acceleration plus convective acceleration. Okay, total acceleration is equal to local acceleration plus convective acceleration. Now, very important thing, for steady flow, local acceleration will be equal to 0, del U by del T, del V by del T, del W by del T. With respect to time, the velocity is not changing. So, for steady flow, local acceleration is equal to 0. Okay, for uniform flow, since velocity does not vary with respect to space coordinate in uniform flow, so for uniform flow this convective acceleration will be equal to 0. Therefore, if the flow is both steady and uniform, total acceleration will be equal to 0. Okay, for steady flow local acceleration is 0, for uniform flow convective acceleration is 0. So if the flow is both steady and uniform, obviously this total acceleration will be equal to 0. If the flow is only steady, if a flow is a steady flow, the total acceleration may or may not be equal to 0 because there may be convective component of acceleration. If the flow is uniform, then the total acceleration may or may not be equal to 0, because there may be local acceleration component. So if the flow is both steady and uniform flow, then only we can say that total acceleration should be equal to 0. Getting this or not? Okay. Next is the tangential and normal acceleration. Now what happens if the flow is along a curvilinear path? Suppose the flow is along this path, a curvilinear path. Okay. Now if I want to draw the velocity at two different points, suppose at point this, the velocity can be represented by drawing a tangent here. So if I am drawing the tangent from this point, the velocity is v. Now at any different point, suppose at this particular point, if I want to represent the velocity, it will be tangent to this point, and the velocity is changing with space coordinate, okay, and velocity is v plus del v by del s into ds. Okay, this distance is ds. Getting this or not? Okay, so if I represent this in form of velocity triangle, okay, so here this velocity vector, which is v plus del v by del s into ds. Okay, now another velocity vector is v. Okay, so the remaining vector will be the difference between the two. This is v, the difference between the two. Okay, this will be del v by del s into ds. Getting this or not? Okay, now this change in velocity, this has two component. One is the perpendicular component, and second is the along this. Okay, so this have two different components. This is del v by del s into ds. Okay, so first is the normal component. So this component is the normal component, and second component is the tangential component. Okay, sorry, this is the normal component, del v n by del s into ds. This is the normal component. Okay, and this is the tangential component, del vs by del s into ds. Okay, so these are two different components. First is the normal acceleration component, and second is the tangential acceleration component. Okay, now this was the convective part. We will have to include the local acceleration part here, and the total tangential acceleration. You can see the proof in book. We will not do the proof here. I will directly tell you the formula. Total tangential acceleration AS is equal to del Vs by del T plus V del Vs by del S. This is total tangential acceleration. Okay. Similarly, total normal acceleration here will be normal acceleration AN will be equal to del Vn by del T plus V square by R. Okay, and in this, as I told you, this del Vs by del S is a convective part. This del Vs by del T is a local acceleration part. This V square by R is convective acceleration, and this del Vn by del T is local acceleration component. Okay, so this acceleration again has two components. First is local acceleration component and convective acceleration component. So for a curvilinear path, just remember this formula, very important formula for numerical. Tangential acceleration AS is equal to del Vs by del T plus V del Vs by del S. Normal acceleration AN del Vn by del T plus V square by R, where these terminologies del Vs by del T and del Vn by del T are local acceleration component, and V into del Vs by del S and V square by R is convective acceleration component. Okay, we will solve one question related to this, and then you will understand this thing much beautifully. Okay, now I will tell you the difference between these two. First is tangential acceleration. And second is local acceleration. Okay, so this tangential acceleration is due to the change in magnitude of the velocity. Okay, you can see here the tangential acceleration is acting in this direction, in the direction of this velocity, in the direction of flow. So this is actually because of the, okay, and this tangential acceleration The tangential acceleration is because of change in magnitude of the velocity. Tangential acceleration is because of change in magnitude of velocity, and normal acceleration is because of change in direction of velocity. For example, suppose change in magnitude of, how will the magnitude of the velocity will change? Suppose the flow is through this type of pipe, the tapered pipe. Okay, so here the direction is not changing, only the magnitude is changing. So here we will have only the tangential acceleration component. Okay, now if only the direction is changing, magnitude is not changing, suppose we are having a constant diameter pipe, okay, but like this, a curved pipe. Okay, so here the direction of velocity is changing and not the magnitude of the velocity is changing, so here only normal acceleration will act. Okay, so the tangential acceleration acts only when the magnitude of the velocity is changing. Normal acceleration acts when the direction of velocity is changing. Okay, so I will tell you the difference between the two, the tangential acceleration and normal acceleration. Okay, so here this is because of change in magnitude of velocity. Tangential acceleration is due to change in magnitude of velocity, and this is due to change in direction of velocity. Okay, now in this type of pipe, in the straight pipe, okay, which is having uniform diameter, obviously there will be no tangential acceleration because the magnitude is not changing, the diameter is same, the magnitude is not changing, the direction is also not changing, so no normal acceleration. Getting this? Now in such a pipe, here the magnitude of the velocity is changing because the pipe is converging. This is a tapered pipe, that means velocity will increase in this pipe, velocity, magnitude of velocity is changing, but the direction is not changing. So since velocity magnitude is changing, so tangential acceleration will act and not the normal acceleration because the direction is not changing. Okay, now third type of pipe is this pipe. Here the diameter is same, but this is a curved pipe, that means the direction of this velocity will change and not the magnitude. So because magnitude is not changing, so this will not be having any tangential component. This will be having only normal acceleration component because the direction is changing. And last type of pipe is such type of pipe in which both magnitude and direction both are changing. This is a curved pipe and the diameter is decreasing, so the magnitude is changing and direction is changing. So this will be having both tangential as well as normal acceleration component. Getting this or not? Okay, so now we will solve one question. The velocity vector is given as 2xi plus yj. Now it is asked what is the acceleration at 1, 1. Okay, 2xi plus yj, that means u is given as 2x and v is given as y. Okay, now you can see here there is no time variable, t is not included. That means the local acceleration component here in this case will be equal to 0. Okay, so the local acceleration is 0 since no time variable here. Okay, now if you want to calculate acceleration, so a, as we know, is equal to under root of ax square plus ay square. Now we know what ax is equal to what, u into del u by del x plus v into del u by del y. Now time component is not included, so local acceleration will be 0. Similarly ay is equal to u into del v by del x plus v into del v by del y. We have already seen this formula. Okay, so just determine all these things. So del u by del x, what will be del u by del x here? So this will be equal to 2. Similarly del u by del y, okay, now since u is equal to 2x, no y component, del u by del y will be equal to 0. Del v by del x, v is equal to y, so del v by del x is 0 and del v by del y is equal to 1, del v by del y. Getting this now? Okay, so just put the value. So this ax will be equal to u into del u by del x. Okay, so this will be equal to u into 2 plus v into del u by del y, which is 0. So this will be equal to 2u. Similarly ay will be equal to what, u into del v by del x, u into del v by del x is 0 plus v into del v by del y is 1, so this is equal to v. Getting this? Okay, now we want to determine the acceleration at 1 and 1. Okay, so now what will be ax now? So this ax is equal to u del u by del x. U is 2x, del u by del x is 2, so this will be 4x plus v del u by del y. Del u by del y is 0. Similarly, ay will be equal to what? U del v by del x. Okay, u, which is 2x, del v by del x is 0, plus v del v by del y. V is y, del v by del y is 1, so this will be equal to y. Now we want to calculate it at 1 1, so this will be 4 and this will be 1. Okay, now acceleration a will be equal to under root of ax square plus ay square, 4 square plus 1 square, which is equal to under root of 17. Answer. So, okay, so this is how we can determine the acceleration. Okay, next question is of curvilinear motion. So velocity is given as 3 meter per second, radius of curvature is 9 meter, rate of increase of velocity along streamline is 1/3 meter per second per meter. The total acceleration is. Okay, so the velocity is given as 3 meter per second. Rate of change, radius of curvature, that means r is given as 9 meter. Okay, and then rate of change of velocity along streamline, that means del v by del s is given as 1/3 meter per second per meter. Okay, now because nothing is mentioned about time, so the local acceleration component will be 0. We will be having only convective acceleration component. So for curvilinear motion, convective acceleration component first is normal acceleration, first is tangential acceleration as is equal to v into del v by del s. Okay, so here v is 3, del v by del s is 1/3, which is equal to 1 meter per second. Similarly, normal acceleration component, tangential acceleration component is equal to v square by r. So this will be equal to 3 square by radius is 9, so this will be 1 meter per second. Okay, so therefore the acceleration is equal to under root of as square plus an square, which is equal to under root of 1 plus 1, which is equal to root 2 meter per second square. Answer. Getting this or not? Okay.